Now we're going to look at a demonstration of a TCP segment. We're actually going to look at a Wireshark capture that shows some TCP traffic. And while it will look different than the diagram does, as I said, the diagram can be a little bit difficult to follow, but when you see how an actual segment looks, you can see how they pretty much map together. In particular, I want to show you just some of the highlights of the fields in a TCP segment, such as a source address, destination address, the source port and destination port, the sequence and acknowledgement numbers and flags and so forth. These are very important to understand for basic packet analysis. So with that said, let's go ahead and look at our Wireshark capture. Alright, we're in our Windows XP box and we're looking at our Wireshark capture. And while I've captured a lot of different traffic, I want to show you a couple of TCP segments in particular. I've got one highlighted right here, and if you look down into the middle pane, we can expand the TCP protocol, and there's some things that we want to go over with you on it. First of all, we've got our source port, so the sending computer sent it from port 1035, and again that was a random port generated on the source computer. The destination port is HTTP, which is port 80. Now that is the port, as we know, for World Wide Web. So this is a World Wide Web and HTTP packet, which is a TCP protocol. We start out with a sequence of 0 and a length of 0. Our source port again listed here, and here's our relative sequence number. Again, sequence numbers are randomly generated, and for our purposes here, the relative sequence number basically means the start of the conversation. It's relative to this particular TCP conversation. We've got a header length, and then we've got flags. Now let's look at the flags that we see here. This will show which flags are set and not sent, and this is a send packet, so the send flag is set. So if you look down through here, these flags, there's all 8 flags here: congestion window, echo not set, urgent, acknowledgement, push, reset, send, and fin. All of these are 0 except one, and that's the send. So we know that that is a send packet. Here's our window size, which as we know, is what the receiving computer can receive at a time. And that's set up front, and if it changes, the receiving computer will send that window size back, saying what the maximum amount of data it can receive is. Here's our checksum, which has been deemed to be correct. And this was generated automatically when the packet was first generated, when the segment was generated and sent out. The receiving computer will basically check this checksum, it'll recalculate, and if it matches, then the segments match and there was no damage to the data in transit. So we've got the checksum here, and we've also got options, different options that we can see. And these basically talk about maximum segment size and other options as well. And after the header, we will see data. So let's go ahead and minimize this, and let's move on to another packet. Now we're looking at the header information. The data will actually be down here in the data pane. Let's look at another one, the one that comes right after it. The first one was a send. This should be a send ACK, because we know that during the three-way handshake that TCP does, a three-way handshake takes place, and there's a send, and the second one is a send ACK. So let's see what we can see with this one. The source port, this is coming back from the web server. So source port is port 80. And it's headed back to the original source port. So these ports are maintained throughout the conversation so that the conversation can be kept track of. The sequence number from the receiving computer and the acknowledgement number, and the header length and the flags. And in this case, we have send and ACK set. So we know that this is the second part of a three-way conversation, a three-way handshake. It confirms the same window size. It hasn't changed that. Checks the checksum. And there's other options here too that we can see. Maximum segment size, as we said before, and it says this is an ACK to segment in frame 7. Frame 7 being the frame above it in the Wireshark capture. So we've got all the data here that we've talked about in the TCP segment construction. Now let's look at the third one in the sequence. This is in segment number 9 here, and let's look at what we've got. Again, same source port and destination port, because this is maintained throughout the conversation. Then we've got sequence 1, ACK 1. So as you can see, our sequence and ACK acknowledgement numbers have increased by 1, and this will go on throughout the conversation. So we can actually keep track numerically of what segments have been sent when and put them all back in order if we need to. Same flags again. This time the ACK is set, window size is still the same, and the checksum checks out. Let's look at our sequence ACK analysis. Basically, this is an ACK to the segment in frame 8, so it tells you that it comes right after that segment. So that's essentially all there really is to TCP header. And as we've seen, the packet construction, or the segment construction rather, is not too much different than other segments. And as we go through the analysis of TCP packets and so forth, you'll use this information throughout the course.